Hey guys, welcome back. Alright, so we have not filmed anything on the race car in a long time, but I want to show you what we've done. So we started working on it a few days ago. So here's our electrical panel. I think it's done. It's 98%. I think it's done. Unless I forgot something, this thing's basically done. Maybe it needs some ground wires. That's probably it. Let me show you what we're working with. Alright. So we'll start over here. This is our warning system. So you get a big green light if everything's good. Then you get, like, say this might be like oil pressure, oil temp, coolant pressure, air fuel ratio, fuel pressure, whatever. These are all configurable, but you get a caution light and a warning light. You know, caution is bad, red is really bad. That's going to have a whole computer to run it, but we'll get to that later. This next one, this is our air fuel ratio. This is from Bailinger Motorsports. It's AFR 500. Something like that. Yeah, that's what it looks like. Version 2, set up for methanol with extended range with a middle of the road sensor. Those are pretty badass for methanol. We're going to have all this stuff labeled. We haven't done it yet. So this is going to be battery voltage. So the car has a 16 volt battery. So you can see your battery voltage because we don't have an alternator. And this is your amps going in or out of the battery. So that means, like, when you're driving the car, you know, it's gonna show some number like, you know, negative 30 amps or whatever. But then when you're charging the car, it'll actually show positive amps to show current going into the battery, which is pretty cool. I always liked having amp meters so you can really see what's going on. For example, I could watch this amp meter, and then when I turn on this circuit, I should see that change. It's kind of like a confirmation that whatever you just flipped actually turned on. Because on a race car, they can be loud. You know, like turning a fan on or something, you may not even hear the fan or the pump or whatever because it's so loud. So having that amp meter, you can kind of know, like, oh yeah, this is a 10 amp circuit, and watch it go from 30 to 40, and you're like, okay, I know that's working. Let's see, next we got some gauges. So these are all from Max Tow Double Vision. These have servo drive. It's an analog dial with 270-degree sweep, and they also have a digital readout as well. I really like these. I think they look cool, and we bought these when it was going to be a street car. Now it's not a street car, but that's okay. So, starting off, we got a boost gauge. It only goes to 35 psi, so I don't know what happens when you go past that, but we will definitely be finding out. Next, we got oil pressure. And then we got, what's the next one? Fuel pressure. So basically the top row, these are like the critical ones. The stuff that if you were actually racing and you were going to look at a gauge, if you're racing, you're kind of looking over here. So this is like turning right and down, and then you got to look down even more to see those. So I tried to put like the most critical gauges right here. Things that could change quickly, like boost can change quickly, oil pressure can change quickly, fuel pressure can just, you know, drop out or something. So these down here are temperatures, water temperature, oil temperature, and transmission temperature. These are things that go up and down, but they don't go like, your oil temp doesn't climb 20 degrees in a quarter second. But your fuel pressure could drop 20 psi in a quarter second. So that's why those are kind of a little further down. This is our spare. We're not using it right now, but we may put like a turbo speed sensor or something else. Anyway, we got an extra. Let's go to our switches. I'm going to be going from memory because I don't remember precisely or exactly, but generally speaking, this turns on battery voltage and battery amp gauges, which is these two right here. This is going to be, I believe, the fuel injectors. This is the ignition coils. I think this is VVT. Hey, I got a cheat sheet. Hold on. Okay, here we go. VVT. Yeah, here we go. Wideband. So switch number 5, that's our wideband. That's kind of nice. Like sometimes you want to turn the wideband and get it like warmed up to temperature so that when you start the car, you've got AFR right from the beginning. Sometimes that's nice. Then we got engine fan automatic, engine fan manual. So for now we're going to be using manual. Automatic is not going to go to anything, but the circuit's in place, and in the future if we have an automatic fan controller, we'll just hook it up, and when you flip the switch it'll be active. Let's see, 2, 3, 4, 5, 6, 7, 8. 8 is our first spare, so this is not used right now. Then we're going to have 9, 10, 11, 12. So 9, this is our gauges. Number 10, this is our running lights. So this is like the red lights in the back, and then in the front there's little lights in the headlamps. That's your running lights, and there's bumper lights in the front. Then we got headlights. This is the low beams for the headlights, only low beams. And then this is the warning system. So this is what drives that panel there. So there's a little Arduino computer that needs to be put together. That turns on the warning system. This turns on the 13.8 volt system. So if you look here, these four that are grayed out are actually supplied by a 13.8 volt system. So when you flip this switch, you'll get a light that tells you that the power is going to the converter, and then the converter is supposed to take battery voltage, which is probably approximately 16 to 17 volts, and it brings it down to 13.8. And so this gauge shows you the output of that system. It should always show 13.8 when this is switched on. That supplies a constant 13.8 to the warning system, the headlights, the running lights, and the gauges. These gauges specifically are not designed to work at 16 or 17 volts, so they required it. These are just light bulbs. You could have run these at higher voltage. They're definitely brighter, but they pull extra power, and they don't last nearly as long, so we didn't do that. And our warning system, we did that as well. This is actually going to have another supply that steps it down even lower, because Arduinos, they run at an even lower voltage. Let's see. Okay, next we got our water pump. So we got water pump, auto, and manual. That's these two, because we have an electric water pump in the car. We got a couple more spares, spare 3, spare 4. The last 3 switches, we got our trans brake, our ECU, and our starter button. So this is just arming the trans brake. There'll actually be a button. Let's talk about that for a second. So we have steering wheel buttons, but I'm not sure if we're going to use these. I'm not sure yet. At least not for dropping the trans brake. What I think I'm going to do, what I used to do in the past, was I had a switch that was like near the shifter, but somewhere you would never accidentally hit it. Because when you hit the trans brake, what it does is it applies reverse. So the way this works, like when you're racing, neutral first. So say you're in first gear, you want to launch on the trans brake. Well, you're in first gear right now, but when you push the button for the trans brake, it actually applies either a piston or a drum or whatever, and applies reverse. So now the car's in first gear and reverse at the same time. And you can imagine if it's, forward's trying to push it forward, reverse is trying to push it backwards, the two jam up and nothing will move. Well, that's the point. It's called a trans brake. It locks up, and now, no matter how much power you put into the car, unless you have like a clutch slip, it's not going to move. But what if you hit that button when you're rolling? I mean, I've done it at 5 miles an hour before. It just locks the back tires up. But what if you did that going like 100 miles an hour? That'd be really bad. The reason I mentioned that, I was going to put the buttons on the steering wheel because they're just super convenient. But I could imagine if you were racing and say you like hit some oil and all of a sudden you're like ripping the wheel trying to like keep the car straight, I could imagine my hand hitting one of those buttons and turning a bad situation worse. So what I think we're going to do is we're going to pick a spot like down there, somewhere that's just completely out of the way, and use that. Somewhere I can still reach when I'm sitting in the car, but it's something I'll never hit by accident. I think that's going to be our trans brake, like the actual, to drop the trans brake. I think that's how we're going to do that. A little bit to be determined, but food for thought. Next is our ECU. So we have MS3 Pro. That's our ECU. Here's our start button. It's a momentary button. We put this on the end for a couple of reasons. One is so you can always like grab like that and push. Just makes it easier. That is a stiff switch. And also it's just far away so you don't accidentally hit the starter. You can see below all the switches there's lamps to show you that, whatever you just flipped is actually getting power coming out of the switch. And this one is a fan that has a manual and automatic. So when you flip this just says that the circuit is like on. And then when this light turns on, that means the fan's on. So this is like the automatic mode is enabled, and this shows that the fan is actually turning. So we're going to add a lamp over here when we do the water pump automatic. We're not doing it now, but it'll have its own light too when it has automatic mode. Okay, that's 9 minutes of showing you the front of the panel. Let's check the back of the panel, because this is where all the hard work went. Check it out. So this is definitely the best wiring I've ever done. It's not like show car grade, but it's pretty good grade. This is like a balance of homebrew and high end. All right, so I'm gonna grab a seat. Let me show you what we did. Let's start with our warning panel. So we got our lamps. These are threaded in, and all of the grounds, you can see here, these 4 ground wires come together. They have little lacing cord knots to tie them together. They come down here. These go into a ring terminal with a crimp and then heat shrink. This is the Racecar DR25 heat shrink. So pretty good stuff. You can see how we ran the wires like this. Looks pretty nice. So I'm super happy with how that turned out. I think this looks fucking great. If you look right here, so these are the harnesses. Like this one does the top row, this one does the bottom row. And you'll note I can pull on this and it's not affecting the wires there because I put strain relief. So this, I made this little bracket right here and drilled a hole and zip tied real tight these to the metal. And then I wrapped them with some abrasion resistant cloth so that when it pushes on the metal, which I deburred, that it doesn't just cut through and like damage the wires. So that's what this spot here is for. It's just for kind of extra protection so nothing gets damaged, because this is a race car. They're going to vibrate and shake, and you know, I can't stand electrical problems, so we're not doing that. Moving right here, well, there's our AFR 500. Nothing really to show there. Here's our gauges for the voltage and amps. So the voltage just hooks right up. The amps has a separate plug for a current sensor. We'll have to install that somewhere off the battery so we can measure that. And then this just goes to the switch like we talked about. Pretty straightforward. So if you look at our switches, so what you're not going to see a lot of on this panel is relays. For better or worse, I wanted to try wiring stuff this way. I've seen this done like in marine stuff and kind of more old school approach, but I kind of like the simplicity. I guess we'll see if this works in practice as well as I think it will. But yeah, there's very few relays. So these are all 50 amp rated switches. If you look at the wires coming out of the back, well, it's not what you typically see. Typically, what you would see on a switch is something like this, like a spade terminal. What you see here is a big fat chunk of copper. Because like I said, these are rated at 50 amps continuous. So real heavy duty, and they actually got screws with number 10 screws bolting them in, which I like just because like the spade terminals, you know, they can get loose and just slide right off. These things are bolted in, they're tight, they're captured, so I just think it's a more reliable connection. And again, everything's crimped and heat shrinked. And I'll try to come back to the crimping in a minute if I remember. But yeah, so here's our fuse panels. So these are from, forget who, Blue Sea. These are actually marine grade components. So all of the stuff inside of here is made out of stainless steel. And again, I just did that for reliability. I really don't like having electrical problems. So these bottom pieces, these are made out of stainless steel. And then these are made out of stainless steel. So I like that just for the reliability side. You can see different gauge wires, like these two beefy ones. These are the fans we talked about for the auto and manual, and then you'll see smaller wires for other circuits. We figured out, we actually, so instead of guessing like, oh, I think so-and-so pulls 5 amps, we took an amp meter and we measured the current draw of every item in the vehicle. The only thing we didn't do is like the water pump, because I didn't have like a bucket of water and a restriction to put on the pump, and I didn't have that level of like testing. But generally speaking, like all those sensors, we went and measured the current and then sized all of our wires and fuses appropriately. We hadn't put the fuses in yet, but we measured all this stuff, so we know like how to fuse it. We knew what size wires we needed. So I thought that was cool. It also showed us that some of this stuff needed like heavier wires and some of it really didn't. Like if you look here, you'll see these two wires are slightly different. This is a 20 gauge, that does the running lights. This is a 16 gauge, it does the headlights. But math says that that's all it needs. So that's what we ran. Also, this is all mil-spec Tefsel. It's like Teflon coated wire. So it's super like man, I ought to show you some of this. Yeah, let me try to show you. So this is the wire. If I can get this to focus. What you'll note, the jacket is really thin. Oh, come on. This camera's betraying me. Sorry. Let me get a better one. There we go. So you see what I'm talking about? The wire, like the actual insulation over it, is really thin, so it doesn't take up a lot of space. And I like that. Makes things go better. Since we're over here, let's talk about our crimping stuff real quick. So here's all the different terminals we bought. So one of the keys to doing good wiring is having the right stuff instead of having to make do with what you have. And this part gets boring, and this is why I didn't film all this, but you have to know what you're going to do. You got to know, okay, do I have a number 8 or do I have a number 10 or do I have a 1/4 inch, you know? What size wire am I using? Because yeah, you can take like a little wire and fold it over itself and stick it in the big one and crimp it and hope for the best. We tried not to do that. We tried to do everything right. So you can see we got all the way down to 2 gauge because we got to do some heavy duty stuff for the battery. Anyway, we got all of our terminals. I'll show you some of the tools that we used. I know it's kind of messy. Here's some more crimps. This is for just doing butt splices, uninsulated. You just put heat shrink over them. But we got those. We even have more than that. We got these, which we haven't used yet, but just in case we needed it. More ring terminals. These are insulated, but the insulation is heat shrink. You can actually shrink it on. So we have that in case we needed it. We got a printer. So this printer has heat shrink. I'll show you what I'm talking about real quick if I don't get too distracted, which we'll come back to the gauges. But this wire, see right there, that heat shrink, I actually printed that, and you can put labels on heat shrink, which is flipping awesome. Like, come on, are you kidding me? That's amazing. So when we start doing all of our critical stuff, the panel will have labels, but the wire where it connects to the panel will also be labeled. So you just match the, like, you know, word to the word when you hook them up. So that'll be cool. Let's see. Here's some crimpers. Had these forever. You can see how that works. We use those sometimes. Here's some south wire strippers. We use those some. I actually prefer these better. These guys are just do a really good job of not cutting the insulation, but only cutting the wire, which a lot of that comes to technique as well. But we use those. Here's another set of crimpers we have. We use these a lot. See if I can find, I think all my examples have heat shrink over it, so you're not going to see it, but these were some nice crimpers. They did a really good job. We use those a bunch. We didn't use these. Those are for insulated crimps, not for uninsulated. Heat shrink. This is that DR25. We got heat shrink all over the place. We also used some marine grade. I forgot I had it. I don't even remember buying it, to be honest. But I did find a stick of this one. This heat shrink is marine heat shrink, so it's got glue inside of it, which is basically impossible to film. You just have to imagine. But basically when you heat it up, the glue inside melts and it creates like a watertight support. And this is a 3-to-1 shrink. So a lot of the DR25 is 2-to-1 shrink. So depending on what I was doing, sometimes I use this, sometimes I use the DR. This stuff is really thick and supportive. So like if I was doing these crimps where I have wire coming out both ends and I want to strain relieve the wire coming out of this, that's where I used this heat shrink a lot more often because it would offer that support. If I was doing something where I needed to make a tight bend with some strain relief, that's where I would use the DR25, or just in general use DR25. We had some zip ties. Can't work on a car without zip ties, but having the right length, that's important. We used this lacing cord, so we got a roll of this. I forget what it costs, but it doesn't really matter. It was totally worth it. Here's the one we used. For anybody that's curious, nylon lacing tape. Anyway, good stuff. We use that a bunch. Super handy. Like we use zip ties sometimes. Sometimes zip ties are the tool to use, but sometimes you need this stuff. Sometimes that's exactly what you need. When we do all of our knots, we would take, see if I can film this probably. I don't know how this is going to go. But like, if this was it, you basically loop that once, loop it a second time, then cinch it down like that. So you get 2 loops on your first knot. You pull that tight, say that was tight, and then you do this a second time, pull it tight, and then a third time, pull it tight, and that leaves a nice knot, and then you cut it off with scissors. But that leaves a really good knot so that they don't like come loose on you with over the years or whatever. So again, just having the right stuff. Sharp pair of scissors to cut that stuff because you got to have that. Anyway, I think that's enough for tools. Let's get back to the panel because you'll see some of the stuff I just talked about was used to build this. Like if you look here at these wires, you'll see these little knots coming off. That's what that is. That's the lacing cord. So just offers support. Like when you try to move this, they move as an assembly and generally they don't move a lot, so it's good for fatigue. Here's our gauges. So the back side of our gauges, the top is like power and ground. The bottom is the sensors that plug in. We haven't hooked those up yet because they go in the car. So a couple things you'll note, this wire makes a big loop in a circle. So like these up here come across like this and loop around and go into this. There's a lot under here. You don't see much. All you see is wires coming out. But inside of here, there's splices. Then they go to like one wire, and then they come out like this. And all the individual ones are heat shrinked and strain relieved. And quite a bit of work under that piece of heat shrink. We had to do it twice. One of the reasons we did this was it would have been cool to make these super short wires like this. Would have been a little lighter. But you can get into trouble doing that. You cut a wire too short, and all of a sudden, whoops, now what? Another problem you run into is when you make really short wires is they tend to pull on the connector. And I didn't want these getting pulled on at all. So you can see, if I bend this out of the way, there's actually a zip tie right as that wire comes out, pinching it against the metal, and then another one right there. And the point is that all this up here, like I can flex this stuff, it doesn't put any movement here. So I should not fatigue the wires where they go into the crimp on these pins. That's why I did that. That's all for, basically for reliability and serviceability. By having these long loops, if I ever did have a problem, or even like, let's just say that for whatever reason I need to like replace this gauge with a different one, or I want to move the gauge like way over there. Now there's enough wire here that you could potentially do that and not just, you know, there's room to work with. You can see we got at least 6 inches of wire extra. Same thing here, it's got a little bit of a loop. And then here, where the important stuff's happening, there's a lot of strain relief. So if you do like this, come down here, you'll see what I'm talking about. It just, again, it's just for reliability. Let's see. All of our lamps, I guess that's worth mentioning. You can see they're grounded down here. Same deal as before. Lacing cord, tying all these little spots for support. Keep it organized, and then they come together. This has the that heavy-duty marine heat shrink we were talking about for strain relief on these. And then just grounds to the panel. Probably the only thing left is we got to run a big ground wire off of the panel just to like ground the whole car, make sure the panel, even though it's bolted to the car, but I don't want to, I want a dedicated ground. Like even though mechanically, right now this is bolted to the table, which by the way made this way easier to do. But when it's in the car, I don't want to rely on this to ground it, even though it may, because this goes into a painted surface. So I'm sure if you tighten the bolts, maybe it grounds, but we'll have a dedicated wire that actually does the grounding. And this will just be dedicated for mechanical, you know, attachment. Just little stuff for reliability. Here's the center one. So this is the 4 fuses that run our gauges, running lights, headlights, and whatever that one was. So let's see. So this is switch 13. We don't have a heavy wire coming off of this yet, but we're going to have a big wire that comes off of here. And it goes to our converter that creates 13.8 volts, and then the output of that ties into this. So I'll show you that real quick, because we do have that part. It's this guy. Took a while to get. This is a DC to DC converter. You just feed it anything from 8 to 40 volts, and it brings it up to 13.8 with a 25 amp maximum. This thing's like waterproof. It's got a big heat sink. Downside, it's kind of heavy. This thing weighs probably 3 or 4 pounds, so that kind of sucks. But they have good reviews. Should work. I haven't actually tested it. But yeah, big fat wires, heat sinked, I don't know. It looks like a quality part. And it's not too expensive. It wasn't cheap, but it's not too expensive. I think it was like $60 or $70 or something like that. But by having that, we can have a guaranteed 13.8 volts and keep our gauges from blowing up and keep our headlights and stuff from, you know, having a really short life and pulling excess current. And I think this thing's like 94% efficient too, so it's not much penalty there. So anyway, that's what feeds this little center block. That's why it's short, because it only runs the 13.8 volt stuff. Back over here, we're back to battery voltage. And yep, it's just more of the same. We routed wires where we had to. This is our trans brake solid state relay. So these wires, if you look here, one of these wires is coming from the ECU, and one of them goes to the trans brake. And so what that allows us to do is the ECU can send commands up to the solid state relay. So there's a thing in drag racing called bumping in. So on this car, what I used to have was that button. That was it. It was real simple. You just push the button, turn trans brake on, you let off the button, and the trans brake turns off. Well, what I can do, maybe use the steering wheel button, is put a bump button. And when you push the button, the ECU will PWM, pulse, the trans brake really fast a set number of times. But you need a solid state relay to do that. Mechanical relays, they're kind of too slow and it's bad on the contacts. They're not really designed for that. Solid state relays are designed for this. So by having the solid state relay, it'll allow me to bump in. So you basically, the car, if you've ever seen drag racing where the car goes bump, 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 you know, they're jumping really aggressive. Those are guys that don't have a bump box. When you have a bump box, you'll see them go toot, 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 like real slow and smooth. That's what a bump box does. So we'll have that functionality by using a solid state relay combined with some setup on our MS3 Pro standalone. So that's kind of cool. We were going to use these relays. These are some 70 amp, like look how big these wires are. This is like the normal size up here, which is for the coil side, but for the switch side, they have these huge fat 3/8 terminals. I bought those from mil-spec wiring and they're rated for 70 amps. I bought a bunch of them. We ended up not using really any of them. But we do have them, so may add something in the future. We were going to use that for the auto relays, the relays for the automatic fans, but we're doing something else now. And lastly, here's our start button. Real simple. You just push to make or break the contacts, and that's about it. So this panel, as far as being done, if you look at it this way, it's kind of flexy. We're going to fix that. Not a big deal. It bolts into the car, but we're going to add some bracing until we're satisfied with that. But we did add a brace over here. This little piece was hanging out. Thought it needed some extra support, so we added a brace to that. Seems fine now. So yeah, we still got to add some bracing. But overall, wow, this is a lot of work. I think I put almost 100 hours between designing the panel, figuring out how it was going to be organized, wiring diagrams, speccing all the terminal sizes for the wire size and for the hole size for every location for every wire, the wire sizes that we needed, designing the panel in CAD, ordering the panels, putting all these parts on the panels, because this requires like just little stuff, but like see these bolts and nuts? I had to make sure that I spec bolts and nuts that would fit in there and they would fit here and they were the correct length, and on and on and on. It's a lot of work to. It's funny, like you look at it now, you're like, oh yeah, it just looks like a piece of metal with some switches and wires. But it took a lot of effort. It probably took 100 hours by the time I did all this, got the parts here, hooked all this crap up. My actual like hands and wrist are sore. And this has happened a few times because I've worked on this so much just from all the crimping. And I have pretty good crimp tools, but it's actually hard. So anyway, I'm glad this part's basically done. I guess one thing I'll mention, if you look down here, you'll see there's some of these are not used. That was intentional. At first, we had designed it to only have the precise number that was necessary. And then we realized we needed like 1 or 2 for something over here. And then we thought about something else, and we quickly realized like, hey, it'd be better to have extras and not need them than need them and not have them. So we stuck as much as we could fit down there, which again, if you look at design, you'll see the gap here and here and so forth. It's all symmetric. That's not an accident. Things like that don't happen by luck. This is all design. I had to go model these parts, like all of these parts, the switches, the thing, all this stuff got modeled in CAD. That stuff's boring. I didn't show all that, but that's how this all turned out like this. It was all designed before it was built. So anyway, tons of work. Hopefully this is worth it. I think it is, because to me, I can't stand having electrical problems. It's something that drives me nuts. It's like you can't really see electricity, you know? You can measure it, but you can't really see it. So when you have electrical problems, you have to... It's just frustrating. I hate having electrical issues. Can't stand it. So I'd rather put in this work now and get it right. And then when I go to the drag strip and I start racing, I don't have to worry about this crap. And even if something does go wrong, like say, not my fault, but like say a part shorts out or something, it'll be easy to diagnose. Because right now, like if my VVT actuator, you know, shorted out, it's only going to flip and blow the fuse for the VVT. That's it. Nothing else is on that circuit. It's a dedicated circuit. And that's why I did that. Because, you know, if you want to test like, oh, VVT on or off, boom, easy. Same thing like, oh, I want to like, say you want to do a compression chest, right? You can turn the injectors off. It's just flipping a switch. Boom, injectors are off. Easy. Or ignition, you know, like, hey, I want to see if I got spark, but I don't want fuel. All right, spark, no fuel. Makes it really easy. You can do a lot of cool stuff when everything's on dedicated circuits. So that's why we did it this way. I think it's going to be, fantastic when you're actually racing. So Not to mention having the gauges and everything and all being integrated into the same panel. I thought that was cool. Anyway, this is fixing to turn into a 30-minute video, so we are going to wrap it up here. If you guys have any questions or comments, let me know. Like I said, this is a huge project, took a lot of work, and this is just a piece of the pie, because as much work went into this, we still got to actually wire the car up, and this is just a piece of that. But like I said, let me know what you guys think, and until next time, y'all take it easy.